All right. So here we're supposed to repeat example 2 for x squared plus y squared minus xy minus 7 equals 0 at x equals 1. And we're supposed to find the equation or equations of the tangent line or lines to the graph of the given equation and point. All right, so first off, what we should probably do is we should probably plug in x equals 1 into this and evaluate and see if we can figure out what the y's are. So if we do that, if we plug in 1 here, and what we're going to get is, we're going to get, well, 1 squared is 1, and then we're going to get plus y squared, and then we're going to get minus, and then we'll have 1 times y, so it's going to be a y, and then we're going to have minus 7, and then that's equal to 0. Well, 1 minus 7, that's going to give us y squared minus y minus 6 equals 0. Well, guess what? We can factor that, it looks like. So that's going to be a y minus 3, y plus 2. That should give us a minus 1, minus 6. And so then y is equal to either 3 or y equals a negative 2. So that gives us the 2 points. And we have 1, 3, or 1, minus 2. So that's kind of our first step here. All right, so next things next is we need to go ahead probably and rewrite this. We'll use our y of x kind of notation, and we'll put our d's and everything else in there. So if we do that, we're going to have, it looks like, d dx of x squared, then plus d dx of, then we'll have y of x squared, and then we're going to have minus d dx, and now we'll have, in this case, we'll have x times y of x, and then we'll have a minus d dx of 7, and that's equal to d dx of 0. All right. First things first, we know that derivative and that derivative are both going to be 0, so we're good there. Now, we get to do the implicit differentiation. So first things first, that first one, the derivative of this with respect to x, that's going to give us 2x. Not too bad. All right, next one. Well, we've seen that one before. We saw that we bring down the 2, so we'll have a plus 2, and then we're going to have just the y of x. And now if we go back and put it as y's instead of having y of x directly, that might be easiest. So that's going to be times a y. Now we need the derivative of this. Well, the derivative of that is y prime. And then we have minus. Now we have x times a y of x. So that's going to need the product rule. And so let's do that. So let's put that in parentheses because we still need to make sure that negatives times the whole piece. And so we'll take our first times the derivative of the second, which is going to be y prime, plus the second, which is just y, times the derivative of the first, which is 1. And so that looks to be that. And now we said that the rest of that's all 0, so we have this. Okay, now let's simplify. So we're going to distribute there, so we have a 2x plus 2y prime minus xy prime minus y equals 0. Okay. Next, it looks like we have a y prime in these two, and so we'll keep those on the left. We'll take everything else to the right, and while we keep these on the left, let's pull out the y prime. And when we do that, we'll have a 2y, and here it looks like we'll have a minus x equals. Now, if we take that over there, we'll have a y. Take that over there, it's going to be a minus 2x. All right, solving for y prime, we divide by 2y minus x. And so it looks like the derivative of y is equal to y minus 2x over 2y minus x. So that's my derivative. And now what we have to do is we have to start evaluating. We first have to find the slopes. We have to find the slopes at 2 points. Then after that, they actually want us to find the equations of the lines tangent to that graph. And so we have to then plug in that point and that point with the appropriate slopes and get 2 equations. So let's do y prime evaluated at, and the first one is at 1, 3. Okay, so we have y, and y, let's say that's 3, and then we have minus 2 times x, which is 1, all over. Then we have 2 times y, which again was 3. And then we have minus x, which is 1. So 3 minus 2 is 1. 6 minus 1 is 5. So let's call that our first slope. And we'll call that 0.1. And we'll call that one 0.2. All right, so y prime, oops, so that's supposed to be a straight line, but that's okay. And we'll do 1 comma -2 now. All right, so y in this case is a -2, so a -2. Oops, what am I doing here? Can't write what I'm saying. Erase. All right, so we have y, which is -2, minus 2 times 1, all over, and then we have 2 times y, which is -2, minus x, which is 1. So now we have a -2, so that's going to give us -4. -4 minus 1 is going to be a -5. That is a negative divided by negative, so it's positive. And so we'll call that one M2. Okay, so now we've got M1 and we've got M2. Now, last time, the problem we did, they only wanted the slopes, but this time they want the equations of the line. So for the first one, we're going to use the point 1 comma 3 and the slope of 1/5. So we just use our point slope formula, y minus y1, which is 3, equals a slope times x minus x1, which is 1. And so we distribute here, so that's a 1/5 x minus 1/5, and we still have y minus 3 here, so if we add 3, so we get y equals 1/5 x, and that's going to be 15 minus 1, so that's going to be plus 14 over 5. So that's my first equation, so let's star that. Now the second equation, we just do the same thing, except now we're going to do 1 minus 2, and we're going to have a slope of 4/5. Okay, so y minus a minus 2 equals 4/5 times x minus 1. And so it's going to be 4/5 minus, oh, that's x, minus 4/5. And we still have on this side, now that's a y, not an x. Y, and that's going to be a plus 2. Now if we subtract 2, we get y equals, we have a 4/5 x, and here we have a minus 10 over 5 and minus 4 over 5, so it's going to be a minus 14 over 5. And so that's going to be our second equation. So that's really all they ask for. They find the equations of the lines tangent to the graph of the given equation and the point. And so these are really the final two things they want. These are the steps along the way we had to do. We had to find our slopes. We had to find those 2 points up here. We had to find the derivative over here. And so that's how we use implicit differentiation to find those 2 equations of the lines. So let's stop there and we'll come back for more.